Gang, I want to talk with you for a moment about something that's near and dear to our hearts, and that is energy. Think about the energy that you have that is emanating from a 60-watt bulb. What does that really mean that it's 60 watts? And how do we measure energy in all of its forms, whether it's what we're using to produce light or sound or Wi-Fi signal? Well, let's take it back a step because when we think about energy, we start off with it in a very kinetic sense. And energy is originally measured using something called newtons and joules that we then translate over time into watts. Here's what I mean. The term newton, right, that is the force to accelerate a kilogram to 1 meter per second. Done any weightlifting, right? Even this is just a 1 kilogram weight being moved at 1 meter per second. All right. So when I just did that, if I had a kilogram weight in my hand, I just used a newton of force. But to create a newton of force, right? That's what you'd feel if it hit you. Well, that took a certain amount of energy on my part, right? I used some of my body's energy. How much did I use? I used what is known as a joule of energy. So a joule of energy is the amount of energy it takes to move a kilogram 1 meter per second. Okay, so that's the expenditure used to create the force. Now, when we think about electricity, right, we can use electricity to do all sorts of things. We use it to power motors, we use it to generate light, we use it to generate RF signals, right? We use all sorts of things in order to, there's all sorts of applications of energy usage. But much of that energy usage is sustained. It's not a one-time deal, it's consistently using energy. And so the term a watt refers to using a joule of energy per second. So if we regularly are consuming something over time, we say that we're consuming that many watts of energy, which refers to joules of energy per second. All right. So that is the sustained maintenance of that particular energy rate. So electricity, we think about a bulb, it's consuming. Maybe it's a 40-watt bulb, or it's a 60-watt bulb, or it's a 120-watt bulb. What does that mean? It means that it's going to consume more energy in order to create the brighter light. Of course, there's all sorts of things that consume energy. Just breathing, right? If you are just a guy and you are breathing, that's a guy, that's a mouth right there. We'll give him an eyeball and some ears so we don't get too freaked out. This guy breathing, inhaling and exhaling, do you know that takes 40 watts of energy? Yeah. When we think about a CD-ROM, the laser used to read a CD-ROM takes actually 0.005 watts of energy to generate that little pinpoint laser. All right, we're not talking about spinning the disc, but the laser itself only takes what we would call 5 milliwatts of energy, right? Instead of writing 0.005 watts, it's much easier just to say 5 milliwatts and let the math be assumed as we refer to the unit of measurement. And when we come to Wi-Fi, when we're dealing with an access point, gang, we can expect an access point on average, there's variance here, but on average we might say that it would consume about 100 milliwatts of energy to do its job. So as we're thinking about Wi-Fi, one of the things that's going to be especially important is looking at the energy consumption, which is going to translate into energy production, right? Or in terms of force and energy and creating that RF wave that's going to move out from that access point. So we start off by thinking of it in terms of watts.